Alright, hello, this is the final part for the real-time top-down combat system that we've been working on. We are going to do the fun stuff like making the enemy intelligence, making the enemy actually do things, making the animations for the enemy and the player, and making the player be able to attack the enemy. This book is doing it with a slingshot that shoots a projectile that arcs, so I'm going to make a fire sword that shoots a fireball projectile. So that's the only thing that I did, was I just imported a fireball projectile from a previous project that I had, and I also have attack animations in 4 different directions. So feel free, as always, to use placeholders or your own sprites. I skimmed through the lesson, and they have 4 new scripts. So in my combat scripts folder, I have a new wander script, a new weapon script, a new ammo script, and a new arc script. So I'll go ahead and get started. My recording software cut out 6 times, so this is like my 7th take, and the audio wasn't working either. So that's okay. First, I'm going to go to the prefab for our enemy. For me, it's the Cranky Crab, and they are using the Circle Collider as the line of sight for the enemy to decide if it's close enough to the player to start pursuing them. So by the way, the wandering is going to work by, first we choose a new destination and a new angle to wander to, and then we go to that, we move to that destination, and then we wait there for an interval that we will set, and then we basically cycle through that again and again. If the player enters through the trigger collider of our circle, then we will pursue the player until they die or until they are out of our line of sight. So make sure that the circle collider is a trigger, and it's as big as you want the range to be. And then you can add a box collider 2D for the hitbox. And make sure that the box collider is the hitbox and the circle collider is the line of sight, because that's how we're doing it for this. If you wanted to have 2 circle colliders, then you could set them as inspector fields to get those references, but we're going to get the references from the type of component that it is. So the first script that we're going to do is the wander script, so I'm going to go ahead and open that up. As usual, this script will be in the folder. It'll be in the Part 3 folder for the real-time top-down combat system in the class assets folder. Alright, so at the top we have 3 required component fields. This means that these components will be required to be on the object that this script is attached to. If they're not, then it will automatically add them to it. So we're going to get a rigid body 2D and an animator. These are the variables that we're going to use. You guys know what variables are all about. The kind of less common one, we've used it before for this, but this is how we're going to store the move coroutine, which is how we're going to determine whether or not we are moving. And then we have the start function. This is how we're going to define our variables, and we start the wander routine. So we start wandering. In the update function, we have the debug draw line, which is a method that everything that derives from model behavior has. We're just going to draw a line from our position to our end position in the color of red, which is just helpful to know where our enemy is going to be going. Our main conda IE numerator is the wander routine, so we are choosing a new endpoint, which we're going to write in a minute. It does what it sounds like it's going to do. And then we are checking to see if the enemy is already moving with this coroutine that I talked about. Because if our enemy's moving, then we want to make sure that we stop it first here before we go in a new direction. This is where we define the move coroutine with this coroutine right here, which we're going to write in a little bit, which is basically going to move our rigid body at the speed that we set, and then here we yield execution of the coroutine for this amount of time that we'll set, and start the loop over again. We start the while loop over again once that time passes. Alright, next we have the void choose new endpoint. This is finding a random range between 0 and 360, which will be the angle that we go in next. Then this line is choosing a random, this line will loop the value, current angle, so that it's never smaller than 0 and never bigger than 360, keeping the new angle in the range of degrees 0 to 360, then replacing the current angle with the result. Here we have calling a method to convert an angle to a vector 3 and adding the result to the end position. The variable end position will be used by the move coroutine, which we have not written yet, and we'll write that soon. And then this vector 3 is converting, let's see what it's converting the input angle from degrees to radians by multiplying. All right, I'm back, I think. Okay, I'm back, I think. It cut me off. Looks like this one's gonna cut me off, but that's fine. I was here. This is where I was. So this is using the input angle in radians to create a normalized directional vector for the enemy direction. Great to have books, guys, for these confusing lines, because that's okay. Anyways, no, we're gonna stop here and come back to this and do the enemy walk animation. We've done animations before, so I'm not worried about this. I'm going to open up the animation window. How do I do that? Where's animation? Animation. No, not that one. The animator. Beautiful. Let's add that wander script to the enemy so that it adds these other, so that it gives me an animator. And we're going to need an animation controller. So I'm going to make a folder here in my animations folder called Crab Animations. And then in there I'm going to make a new animation controller, call it Crab Controller. Hit that on my controller for my crab prefab, so I just drag that into the animator component. And then we're going to create a new animation and call it Crab Idle. Hit the loop time. Click it again in the content browser, press Control D and call it Crab Walk. And then we're going to double click that, open it up, make it a little bit longer, and go to my sprites, wherever you have your sprites. Gonna drag in some of the idle ones for the crab idle. Oh no, you have to make sure that you have it selected before you grab in the, it has to be selected, and you actually have to drag the animations that we just made into the animator, like that. So now when I select it, I'll see crab idle becomes not gray, and I can drag in the animations. And I can't set the frame rate, so I'm going to go to these three dots in the corner and add show sample rate. I'm going to set this to 12. Then I'm going to hit the drop down to go to the crab walk, set that frame rate sample rate to 12 as well, and then find where's the walking ones? I think this is walking when he's got his little claws up. Okay. So now I made the animations for the crab. It's going to want us to create a parameter, so not a base layer. But if you go into the animator tab and in the top left you'll see layers and parameters, click on the parameters and then click on the plus to add a bool and call it is walking, and make sure that the I is lowercase and the W is capitalized. What's next? What do we do next? Is that okay? So I'm guessing let's go ahead and make a transition from crab to walk and walk to idle. So I did that just by right clicking on the animation in the animator window, make transition, and then click where you want the transition to go to. I'm going to click on the transition from idle to walk and uncheck has exit time and bring the transition duration to 0 because this is a 2D game. I'm going to go down to the conditions and press the plus button, and that looks good. Is walking. When that bool is true, I want to be walking. When that bool is false, so I just clicked on the other transition, then I want to be idle. And then you also want to set this exit time and transition duration to 0. So that's what that's going to look like, I'm sure. That's it. Okay, great. Now the move. Now we go back to the script. Alright, now back to the wander script. We'll pick up where we left off, which is right here in the IE numerator move method that we made. The first thing we're doing is calculating the remaining distance with this square magnitude property that Unity provides that is an approach to performing quick vector magnitude calculations. Because we're going to use this remaining distance float to determine whether or not we are on top of our target or not. Because if it's greater than 0, that means we are, and we don't want to perform this loop. We don't want to move towards the target if we're on top of them. So we check if the target transform exists or not, which will be set. This is going to be set to our player later on if we are within range. Otherwise, it's just going to be our target destination. We set that to end position here, if it exists, and then here we check if we have a rigid body, because this move towards method that we're about to use requires a rigid body. So after checking that, we set the bool that we just made in the animator to walking. We set it to true, which will trigger our walking animation. Then we define this new position vector 3 as this vector 3, which means it's just like 3 parameters that we need to set, which is our rigid body's position, our end position, which we set here, and then speed times time dot delta time, which I'm fairly confident is how we make sure that we are moving at the same speed regardless of the frame rate of the device that you are using. And then we set this rigid body dot move position to new position, so we just set that, and then we go there, and then again we're calculating the remaining distance again the same way that we did up here. And then we do the yield return new wait for fixed update, which looks like that is yield execution until the next fixed update. So okay, cool, simple enough. And then once we get there, once this loop is done, then we go back to idle in our animator. So that's looking good. I'm just going to keep moving through this script because, get it done faster. It's a Saturday, guys. Might as well do this as quickly as we can. Void on trigger, enter 2D. Okay. This is if the player tag collides with us and follow player is set to true, then we want to change our speed. This is where we set the target transform up here for there to the player to whatever collided with us, which is going to be the player. And then if we check if we're moving or not, and if we're already moving at this time, we want to stop moving so that we can change and move towards the player, which is what we're going to do right here. Beautiful, beautiful. All right. And then we have the void on trigger exit 2D, which is if the player exits our collider, then we stop walking and current speed goes back to wander speed. So this is interesting. I assume because the enemy is going to start moving faster that the player is not just going to keep moving back and forth between their line of sight. Maybe the player has a dash or something that could get it away from the enemy. And then once again, if we're moving, then we stop that so that we can proceed with other methods, and target transform then goes back to nothing so that he can continue wandering to its default end positions. And then finally we have a void on draw gizmos, which is it's just for debugging purposes. And it's going to draw a wire sphere according to our circle collider so that we can always see the range of the enemy, which is not totally vital, but it's a cool little thing to know about. So that's the wander script. I'm going to save and go back to the Unity editor, set these variables, and alright, so before it actually works, I had to go to the code, and before it was in the move method in the while conditional statement, it was remaining distance had to be greater than float.epsilon, which is basically 0, but I found that the enemy is always moving a tiny little bit for whatever reason. So instead of using this fancy float.epsilon, I just made it 0.2f or something very small. Save and go back. And just another couple things to do on the enemy prefab before testing is going to the enemy prefab in the rigid body. Under the constraint setting, freeze the rotation on the Z so it doesn't go flying in circles. And then because it's a top-down game, we can set the gravity scale to 0. Oh yeah, for the settings, I used 1.4, 0.8 wander speed, and interval 3. And then just for debugging purposes, he's not going to follow the player right now because I don't want that stress in my life. But we can, okay, go ahead and start. I think that's pretty awesome. So that's good for now. Alright, now I'm going to make the ammo prefab really quickly. You can call it ammo. I'm just going to create an empty game object. Mine's going to be called Fireball. And then I'm going to add a Fireball sprite to it. So I'm going to add a sprite renderer component. And add one of these Fireball sprites that I have. And I think I'm actually, I'll put it on the, well, I'll make a projectiles layer. And put it on a projectiles layer, sorting layer. And it's also going to want us to make a layer for ammo. So I'm going to add layer, make one called ammo, go back to the Fireball and set it to ammo. And we only want that to collide with enemies. So I'm going to edit, preferences, physics. Where's physics? It's not here. So edit, project settings, physics, and then in the ammo layer, uncheck everything except for enemies and ammo as well. It'll collide with other ammo as well. So it should look like that. So if that's it, if your projectile is just a static projectile, that's good for you. I'm going to make mine animated as well. So I'm going to create an animation and call it Fireball idle, I guess. Make it loop and drag that onto the Fireball object in the hierarchy. That made it animator controller automatically. So in this window, look, it's already by default going to do that, but I'm going to double click this, right? Well, no, I'm going to press Control 6 to bring up the animator window, set the frame rate to 12, and drag in these Fireball sprites. But I have to make sure it's selected in the hierarchy. So now my projectile is animated. Alright, so now we'll make the enemy scripts to go on that. The 3 classes that we're going to make are the weapon class, the ammo class, and the arc class. The weapon class is going to be for determining when the input is touched. For us, it's going to be a mouse click. It's going to change the animation to a firing animation, and it's going to be what instantiates the ammo and shoots it toward the target. The ammo class is going to be how we determine when we collide with the enemy, how much damage it does, and the arc is going to make the arc for the projectile. So starting with the ammo class, I'm going to open that up. It's very simple. We determine how much damage we do with a public integer that we'll set in the inspector. Then when we collide with a box collider, which I would do this as like an enemy tag, and then you just compare tags, but this is fine for now for the sake of time. Then we get the enemy component on the enemy, and then we start the damage character method that's on the enemy. You can see that's right here. I just switched to the enemy script. It's going to call this method back to the ammo script, and then it's going to set the ammo to false. So later we're going to do object pooling so that it doesn't get too expensive. Alright, I opened up the weapon class, and this is where we're going to be doing a lot of the object pooling logic. How object pooling works in general is instead of instantiating and destroying objects, which can be expensive, we have a pool of them, so we have a group of them already there, but they're inactive. Whenever we need one, we just take one from that group and activate it. When we're finished using it, we place it back inactive in the pool. So this is where at the top we'll set the ammo prefab. This is going to be our list of game objects, which is going to be our projectiles. This is going to be the maximum pool size, and this is going to be used for the arc class. We'll see what that's all about in a little bit. Here, if it's null, then we create a new ammo pool. That's great. For here, we create a loop using pool size as the upper limit. On each iteration of the loop, we instantiate a new copy of the ammo prefab, set it to inactive, and add it to the ammo pool. So soon we'll see when the player uses it, it'll grab an inactive ammo object and activate it. And when it's done, it'll be deactivated and returned. So exactly how I explained it. Here, we check if we put the mouse button down. 0 is the left click, 1 would be the middle button, and 2 would be the right click on your mouse. And we're going to call this fire ammo method down here. I'll talk about this one first. This is the spawn ammo method. For each game object ammo and ammo pool, this is where we set it to true, and it's going to go to whatever location we have here as the argument, which is we set that here, which is basically just going to be on our player's location, transformed opposition. And this is called from, this is called from here. So when we click, this is basically going to get the position that we click with our mouse and spawn the ammo on our player. And this is for the ARC script, which I haven't looked at yet. So we'll see what that's all about. So I guess we can save the script and go back to the Unity editor and then add the weapon script onto the player. And I'm going to go ahead and make the fireball, my projectile, into a prefab by dragging it into the content browser, clicking on my player, and then dragging that projectile into the ammo prefab slot on the weapon component. Change the pool size to 7 and the weapon velocity to 2 for testing purposes, and then apparently that should work. So let's see if that works. I had to go to the fireball prefab and add the ARC script, which we are about to create, and also a circle collider on it, which I forgot to add before, and make sure that it's a trigger. Alright, so this is the ARC script. If you want this is basically the math of how it goes. If you want the details on it, you can look at the scan center in the class folder. This is what it looks like when it's going to go in an arc. I think I'm not sure if it's done yet, we'll see. Before I just had it going in a straight line, and that's because it looked like this. So if you want your projectile to go in a straight line, this is what that looks like. But we're going to be making it go in an arc. I think next we're going to be doing animator stuff. Alright, the next step is to make a blend tree for our firing of our weapon. Luckily we've done this before and it's exactly the same thing that we've been doing. I'm going to go open the player prefab, and then I'm going to go into the animator window. In the parameters tab, I'm going to make a new pool called is firing, lowercase I, capitalized F, and then I'm going to make a blend tree, and I'm just going to duplicate my walk blend tree by right clicking, copying, and pasting somewhere else and renaming it to fire blend tree, or maybe attack _ BT, which is the naming convention that they use in Unreal Engine, which I think basically after everything I just do underscore and then the initials of what it is. So whether it's a material, texture, blend tree, I think Unity should use that more. Anyways, now I'm going to create, let me just go ahead and make the blend tree. No, we have to make the animation. So I'll just make one animation and then I'll do the rest off camera, but just in case anybody needs a little bit of a refresher on that, feel free to skip this part if you already are good with the animations. But I guess I will duplicate, I'll just make a new one. Create animation. I'll call this player attack south. I'll just use down. Make sure not to check loop time. Open that up, make sure the player is selected, then find it again. Oh no, I have to drag it in. You could just put it directly into So I know that's going to go there, and I'll go over that in a second. So now I'll see that in my player's list of animations. Start it off with 12 frame rate, go to my sprites, and I need to slice open my attack sprite. So just as a little refresher, I know my pixel per unit is 32, sprites mode is multiple, no compression, and point no filter for the filter mode. Apply the changes, go into the sprite editor, and this is where we're going to slice it up. Slice automatic, change to grid by cell size, and then I know these are 128 by 128. Slice it up, apply, and now that's perfect. And now I can drag him attacking downwards, which I know are... Oh, it's so small I can't see. Let me make it bigger, bigger. Okay. Perfect. This is him attacking downwards. And double check how that looks. Perfect. And do that for all. Alright, so I just made all of the animations the same way I just showed, and I dragged them into the blend tree here. Now, setting up these input fields, it's just like if you're thinking about X and Y on a grid. If you're doing the right attack, right on a grid would be going up 1 on the X-axis, up would be going like up 1 on the Y-axis, down would be like going down 1 on the Y-axis, and so on and so forth. So it should look something like this. And then back in the base layer of the animator, I'm going to make the transitions to my attack blend tree from idle and walk, the same way we made the transitions before, going to and from attacking. So dealing with the transitions going from first, I'm going to make sure there's no exit time and no transition duration, but the condition is firing is true for both of the transitions going towards the attack blend tray. And then going back, there's actually going to be 1 second of exit time because the animation is roughly 1 second, and you can play around with that. And you also want to make sure the condition is set to is firing is false, and do the same for both transitions going back from firing, back from the attack blend tray. So that looks pretty good. Alright, back to the weapon class here. Sorry if this is not the smoothest transition because I've been actually typing for 30 minutes. But this is gonna get into some fairly complicated stuff, probably more into intermediate C#. If you have any questions on the details, feel free to look on the scans that are gonna be in the folder. But I'll explain it here. And the first thing I did was add some variables to the top. It requires an animator now, and I added an enum, which is basically going to describe the direction that the player's facing. Then some stuff we already did, and then the first new thing I added was the get slope algorithm here, which is using the equation. I mean, it's all using y equals mx plus b. Here we're doing y2 minus y1 divided by x2 minus x1, which equals m, where m equals slope. And that's what that looks like written out. That's going to be the algorithm that we use. And then in the start function, we are going to use, yes, the get slope method here. But first, we want to create these 4 vector 2s, which are going to represent the 4 corners of the screen. And then we're going to create 2 bools at the bottom here, these 2 bools, which are going to be, which is how we're going to calculate where our mouse is clicking. So here we decipher if the mouse is clicking higher than the positive sloped line, and here we calculate if it's clicking higher than the negative sloped line. This method, get quadrant method, is responsible for determining which of the 4 quadrants the user has tapped in. And it does that by sort of similarly to how we program the blend trees. So by process of elimination here, and then we return which quadrant it is, which then will go up to the update state method. Quadrant quad enum equals get quadrant. So that value is being returned right here, which will then be the state that we're in. And then, as you guys know, because we talked about switch states, whatever quadrant we are in will end up setting the parameters for the move X and move Y parameters that we set in our animator a long time ago when we were doing the walking animations. So these things are these 2 variables right here, which also determine, basically every animation that we have so far. Okay, so with that all set, we also set the is firing bool to true, which is the condition that we set to go into those animations. Anything else? Let's see. That's the very simple gist of it. So this script is of course going to be in the file. I'm going to save it and go back to Unity. Press play. Alright, we have one more thing to do before we get to see it in action, and that's because I realized that the book actually talks about a much easier way to make the character flicker than what we did before. So, that goes to show when you look at things that are written by professionals, they tend to be better than some random YouTube channels, but it's fine. In the character class, in that class, so that it could be on the player and the enemy, we just add this short method here, i.e. numerator flicker character, which just gets the sprite renderer and change it to red for a split second. And then you can go to the player class where the player takes damage, and the damage character, i.e. numerator, add that coroutine instead of the flash effect that we had before. And then you do the same for the enemy. Add that start coroutine flicker character. It's a little bit weaker, so maybe you do want to use the one that we had before. Either way is fine, and I think it's good that if you've never used shaders before, you got to see how that works a little bit, and just see how easy it is to add new things. So with that done, we can go back to the Unity editor. I don't know what's wrong with me, but I forgot to add the ammo component to our projectile prefab. So whatever your projectile prefab is, make sure you go into that prefab and add the ammo script to it, and also set a damage inflicted number. My crab only has 2 hit points, so I made the hit points 1. So after that's all good, then I'm going to test it. Hopefully everything works. It's working great. See, now you can actually see that I have an arc. Depending on where I click, the arc is higher or lower. They take damage with blink instead of So the arcing mechanic actually makes it a lot more fun. If you have a slingshot or something, it's perfect. So I think this was a success. We got into some more intermediate C# there. Got a little bit complicated, but it functions great. It looks great, and it's fairly a lot. There's an inventory, there's health, there's damage, there's artificial intelligence, enemies that actually do things, which tends to be a little bit harder for 2D projects. And I think it's fun, and it's a great start for other things to do. I'm going to try to mix this inventory system with the quest system that's in the documentations that's on Canvas. So we'll leave it there for now. If you made it this far, I think you can pat yourself on the back a little bit, because it's not all of this was easy. But anyways, that's it for now.